Sure. Thanks, Antil, for confirming. I noticed only 3 people have joined the webinar so far. So I shall wait for another 5 minutes so that others can join in. Simple, my name is Pawan Kalurkar. I handle manufacturing solutions, applications for Altair Engineering. Senthil and Soumitra, can you check with your classmates if they too are joining the webinar and if they have registered as well? Is Danish available in the webinar? If Danish can hear me, I would suggest you to contact your classmates if they have to have registered for this contest to join this session. Thank you. Good morning all. This is Pawan Kalokya here again. I was waiting for a couple of other attendees to join, but looks like either they are not aware of this webinar or they could be sharing or sitting along with a couple of you guys. I'll start off with today's session then. In today's webinar, I will be focusing on three major topics. That would be the meshing criteria when it comes to meshing your tools as well as your blank components, and then followed by setup of one-step forming, and then I'll also take you through the process of incremental forming setup, both through auto process as well as through user process. So as I was mentioning, this webinar will contain three topics. One is the meshing basics, which is valid not just for forming setup but for even other types of analysis. Could be linear static, could be other type of analysis. After that, I will be taking you through the steps for setting up one-step forming, and then finally I'll be taking you to the process of incremental forming and post-processing, which is how to visualize your results. So once you have installed HyperWorks, you will be able to see HyperWorks 12 or 13 based upon your operating system in your start programs list. In order to start HyperForm, you need to come to HyperWorks, Manufacturing Solutions, HyperForm. So once you click on HyperForm, you will be prompted with this window. This is called as user process, where you have an option to select HyperForm, HyperMold, HyperExtrude. Currently you are only doing the forming process, so you need to make sure the option is set to HyperForm. And currently you will be doing one step. Later when you are doing incremental radius, you need to select the incremental option. So I am going to select the one step. So this is the graphical user interface for HyperForm one step. This is similar to that of all the HyperWorks applications, wherein you have the pull down menus at the top. These are called as the pull down menus. Then you have the standard toolbars. These are the standard toolbars. These are specific for HyperForm. And again, you have separate toolbars for visualization as well as for display options. This is the graphics window in which you are going to view your model. On the left hand side, you would see the utility model and one-step browser. You can check all the entities in your model in the model browser. And in one-step browser, you can finish your complete setup for your one-step forming. So before starting off with one step, let me give you some brief understanding of the meshing techniques what you could follow. So for this model, I will so here is one of your standard components. So this is the visualization option for your geometry. This is for your mesh or FE. So here you notice this is a sort of a draw option. And at the end of your lines, you would always notice these dots. These are called as fixed points. Senthil, you can type in your query and I will answer either at the end of the session or somewhere in the middle after each session. So you can hide these dots using View, Toolbars, Display, this button here, Display Fixed Point. So this will hide it. These fixed points will affect your mesh flow, hence they should always be hidden. So here is one component typical of your forming stages. So once you load your geometry, could be any format, could be IGS, could be step or parasolid. In step and parasolid format, the possibility of they being solid geometries is very high. Hence you need to extract the mid surface. Else if component is already extracted, like the one in the graphics window, then you can directly start off with meshing. This is for the mid surface directly. You don't need to extract the mid surface of this component. So once you load the model, spend some time in understanding how the model is. What is the smallest edge in your geometry? What are your features which you need to capture during this meshing options? So you can use the F4 panel. If you hit F4 on your keyboard, it will take you to the measure or the distance panel. You can specify the 2 nodes option. Once you are at the end of the line, it will show you a red square box with a dot in the middle. Click there. So this will give you the total distance. So the general rule of thumb is you need to have at least 4 elements lying on this edge. Hence always make sure you do check all the smallest regions in your components such that they should always be captured in your meshing operations. This feature is barely 3.4 units. HyperForm does not have any unit system. It follows the same unit system as your model. If you have designed the model in unit system in a CAD environment, then you need to use the same unit system. Then this dimension will become 3.9 millimeter if this model was modeled in millimeter units in a CAD environment. Could be CATIA, Ploi, any of the CAD software. So you need to always ensure that you are following consistency in your unit system. Everything has to be in respect to the same unit system. For example, if your model is in then the density value has to be in terms of kg per millimeter cube. Your stress values will later be with respect to Newton per square. So you need to always follow the consistent unit system. and not necessary that all the times you will find a component to be imported very clean way. There could be some extra missing surfaces or duplicate surfaces whenever you are going to explain some of the common issues when you import your CAD geometry. I will show you in HyperMesh block format. This is how you change the options between your user profiles between HyperMesh and incremental or one-step radius. So when you import your component, there could be some missing surfaces like this, or there could be some duplicate surfaces. So you always need to make sure that you have set the display options to by 2D topo or topology mode. Topology is nothing but the definition of your CAD geometry. So once you change it to topology mode, you would see some red lines between your surfaces, which means these surfaces are not connected to the next surface. You'll also see some yellow lines, which means there are duplicate surfaces which are lying on top of each other. Here you would see a gap between your missing surface. Here again you would see duplicate surfaces. So you can come to geometry, defeature, duplicates, surfaces, all, you find it. So with a cleanup tolerance of 0.5, 0.0035, it couldn't find. So let me change it to a value of 0.1. Since the cleanup tolerance is way too small or way too large, it will not be sometimes able to find it. But the visualization mode will always show you the yellow line, which means there is a duplicate surface. You need to go to F2 panel, which is the delete, change asset type to surface, delete the entity. Now if you see, it changed to green, which means these surfaces are connected to each other. Red represents disjoint surfaces. So these two surfaces could be disjoint. There is a missing surface here. These two edges are not connected to each other, since there is a, here again there is a duplicate surface. I click on it, it deleted. The moment I deleted, it changed back to green. You also have few bold location holes here, which you can fill them. You can specify the range. Anything less than 10, it will ask it to find. So this will plug it. So all these hole locations got plugged. In one step, there is no effect of these holes, so you can very well close them or plug them such that they won't affect your mesh flow. Now next you have these fill up surfaces. You can go to F11, which is quick edit. You can come to fill a surface. Just select the edge, it will automatically fill it. There aren't any missing surfaces here. So what I would suggest is, in order to change or stitch these red edges, you can come to geometry, edit, surface edges, equivalence. Click on surfaces, displayed, click on equivalence. You notice most of the surfaces got stitched. So you can try another iteration to check if these two get stitched. Set a value of 2. If sometimes it doesn't stitch it, what you could do is, you can come to F2, delete the surface. See, there was a duplicate, due to which it was creating an issue. So you deleted the surface, it fixed the issue. The whole idea of cleaning up your geometry is that your mesh should align with your geometry, else there is no point in you meshing the component when it doesn't capture your. So ultimate goal was to plug this. So I deleted the two surfaces and created one single surface. I hope it's clear to you now. You can import any of your, in the import options, you would see 4 formats. One is your model file, which is your HyperForm file. This is your solver deck, which will be a radius file or a param file. This is import geometry. This is import connector. You will not be using the connector options at all. You will be only using either of these 3. In the import geometry, you can see we support ASICS, CATIA, TXF, FiberSim, IGS. Most of the commonly used geometry formats, JT, Parasolid, SolidWorks, STEP, UG, everything. So you can export your CAD geometry, your skin for your component, which is to be extracted for a mid surface in any of the format. Can be IGS format, STEP, any of it. So I hope you are clear about the process of cleaning up your geometry. Now come to one of the other important options. Once you have cleaned up, you need to mesh, because this is a finite element of, you're not going to run your simulation directly on your geometry. As I was explaining earlier, you need to measure the smallest features in your component and make sure you put it into by 2D topo mode so that you do not see any red surface on the middle of your surface, red lines, which denote free or disconnected surfaces. You can import even your solid geometry, but then you still have to generate a mid surface for your blank or your component. You run all your forming simulations based upon the mid surface, not on a solid blank. So once you have cleaned up, there are multiple options for meshing. One is the model. I'll delete the so this is the part here. Come to right. This is the one-step browser. Part, add a new part, which is this name. So the moment you add a part, it will automatically populate with material and thickness, default values, which you can change at any given time when you are setting up. So but before assigning the material and thickness property, you need to mesh it. So we have already removed the holes, we already cleaned it up. So you don't need to go through these two options. Once you have done with the cleanup and removing of the holes, you have two options. One is R mesh, next is auto mesh. R mesh is called as rigid mesh. It doesn't give you control over the quality of mesh. So here I specify the minimum edge length of the element, maximum edge length. Ask it to mesh. So if you have a look, it generates many triangle elements or trias in the curved regions. And the trias being one of the most stiffest shapes, you will not see the right projection of these element edges onto the surface, which will give you a smaller edge line when you go for unfolding your component to achieve the flat blank shape. So it is always suggested to avoid triangles in your blank. Now you cannot make any modifications to this mesh. You cannot reject it as well. So what you could do is come to F2, which is your delete panel, change entity type to elements, hit all, delete. Next option is auto mesh. In the mesh you have auto mesh. Even B mesh works similar to R mesh. The results would always be similar. The best option I would suggest is auto mesh. It is, the shortcut key is F12. So this has multiple algorithms. One is size and bias, next is QI optimize. You would be using one of these two options, size and bias or QI optimize. So here in the mesh type, you should always be using quads only for your blank mesh. Your tools can have triangle elements, that doesn't matter. For the tools, your punch, binder and die can have the triangle elements because your tools are treated as rigid bodies, so it doesn't matter if you have triangle elements. But if you can avoid it, it's very good. Else your blank should not contain any triangle elements at all. So always go for quads only. I will specify this with a size of say 5. Display mesh. So if you see, it has captured this region quite well, but it didn't create much of these elements in this zone here. So you can control the node seedings on each of the if you see, it has fairly captured this region, the small curvature regions. This is how you can control the number of elements on your edges or your features or your fillets. These regions are called as fillets. You should always make sure at least 4 elements are sitting on top of your fillets. For one step, it doesn't matter if you have too many elements, but for your incremental forming, you need to be very judicious in your meshing, because if your machines are not capable of handling too many elements, then you need to be very judicious in your meshing. That's where your meshing skills are important. So I can say reject and come out. Instead of size and bias, I'll go to QI optimize. Here, similar to the size and bias, you have all these 4 options, but here you have option to edit the criteria. This criteria file contains target element size of 5. The minimum it is going to create is 1, but I don't need any one size element. If you remember, the smallest fillet edge was around 4 in size, so it can fit in minimum size of 2 there. Max can be 10. You don't need to worry about the aspect ratios. These are all the default values. Once you change the minimum and max size, you can apply. OK. So this is an iterative process. It meshes, compares with the criteria whatever we have set. If it matches with that, it exits out. Else, it is going to keep on meshing. So here it will mesh the top region with coarse mesh and the other regions with slightly finer mesh. You can reject this. You can also use edge deviation, minimum element size of say 2, max of 5, quads only. By default, if you see, it has created 2 elements here. It has captured these regions. On the top, it has created some good quality and some bad quality elements. But overall, it has created fairly good quality. So if you want to mesh only the top region, I can come to elements, select one element, click on elements button, by face, or you can create one set for these top elements and then ask it to remesh. I'll set this option to 4. So these are different algorithms by which you can mesh your blank. Wherever this sort of curvatures will come, due to this, your mesh flow will always get affected. So I'll go to auto mesh. So this has fairly captured this region. I can change the element to shaded element. This is not geometry, this is already a shared element. I can hide the geometry from the model browser. This is for geometry, this is for mesh. You can make some basic CAD, but I wouldn't suggest you to use it for generating your CAD because the quality of the surfaces may not come as good. So I would suggest you to use some CAD software to generate a good quality CAD. So I have already meshed this component. Now I can select, if you right click on this, you will get database. So this is a standard database for your one-step forming, all the SAE materials that can be used. So here I am going to use HRCQ, which is hot rolled draw quality, or you could use any of your standard material properties. So this would be the material properties for assigned to this blank. Young's modulus of 2.5 or 5, Poisson's ratio of 0.3, tensile strength of 386, strength coefficient of 640, yield strength of 268. So your yield starts at 268 MPa for this material. So I'm going to select this and I'll activate the thickness, make it to 1.2. Now I'll come to setup components. Component will be your part. This is the component. It will automatically select the material which is assigned to it. Material is HRCQ. thickness is 1.2, just update it. So this blank is now updated with, I'll delete this ERDQ. Let us change the material type to, so if I change it to by matte, so this component has been assigned with its thickness and material properties. Now, depending upon the type of component, if this component is having draw beads, if this component is required to form using a blank folder, you can add blank folder. Else, if this is a crash formed component which only requires a punch and the die, then you don't require to set it as a draw forming. You can set it up as crash forming. So you have the process of crash, draw and simple bend. Crash forming is stage where you only use the punch and the die. You do not have the binder. In the draw forming, you will have the effect of the binder or the blank folder on your blank. So let us first check the option using crash form. The moment you set it to crash form, these two options get hidden. So after you have assigned your blank with thickness, material properties, everything, you need to save as. This will be saved as an HF file. You come. But before running, you need to make two checks. One is the auto tip, then next is the undercut check. Auto tip is to rotate or orient your model such that it lies perpendicular to the z-axis. Your forming direction is generally set to the z-axis, but you can form it in arbitrary directions as well, based upon the y or z, or even with respect to a vector. So I will set this option to z-axis. Come to auto tip, activate the component, select it, click on calculate auto tip. So it says it needs to be rotated at this angle. Click on auto tip. So now this component is oriented perpendicular to your z-axis. Flat plane is perpendicular to the z-axis. Also, you want to check if you are going to face any undercuts or issues while ejecting your component from the tool, which you can check it in the undercut check. Come to components, activate it, check undercut. As per this, these are the regions where you could see some issues while ejecting. This region could get stuck to your die or the punch, which are as per your moving tool. Again, this region will get stuck. You can correlate this using after you run your one-step forming. So make a note of these regions, this wall here and this region here. How can you get rid of it is by providing some draft angle to this wall. This wall most probably will be 90 degrees. So you need to provide a positive draft angle, say of half a degree or 1 degree, such that this region will get formed plus also get easily ejected from the tool. This has to be done or modified in your CAD environment. So once you have done the outer tip and undercut check, again save the file, then run your simulation. I'll select this same file. It starts the one-step solver. Now after you have run, you would now see these results getting activated. Earlier they were not available. So let us first check with the most important result, which is the formability. If you remember, this was a region wherein it had predicted some undercut, which means here you will see wrinkling occurring. You will have more metal remaining here, due to which you will see wrinkling occurring. And again in this region as well. There are certain regions in your blank which could lead to failure. Currently they are just above your marginal line, so you do not have to worry. You should not have any element lying above the red, which means the element would have got tone, or your blank would have got tone in those regions. But this component is not getting tone, just on the verge of failure. This is called as forming limit diagram or forming limit curve. First, based upon your blank thickness and your strain hardening coefficient, this point is calculated. Then these two curves are plotted 45 degrees to each other. It's offset down by 10 or 15% based upon your marginal value, whatever you have specified. Then way down below, so that your minus strain, you would see your good line or your proper forming line. Anything below that will be compression, above that will be forming good. Anything between your forming limit curve as well as your marginal line will be green. Above the marginal line will be yellow. Above the red line will always be red, which means those elements have got completely distorted or thinned or teared. There is a tearing in the blank in that region. Now you can see the percentage thinning results. This region has got thinned by about 24%, wherein this region here has got thickened by around 10%. Even these regions are getting thickened, where you have seen the wrinkling occurring. Here was the maximum wrinkling. You see close to 20% reduction in or increase in thickness. So this is the thickness variation result. Now you have blank shape. So this is what you were looking for. You want to predict this blank shape, based upon which you are going to order your material that is required to form your component. It could be in the form of coil, or it could be in the form of sheets. You can also do a nesting as well to check how material utilization occurs. Wrinkling can be avoided by multiple approaches. One is increase or decrease your binder. If there is no binder, then add a binder in your forming stage simulation. Then you can also use draw beads in certain regions such that it controls the metal flow. Draw beads are sort of features that are used to control the metal flow into the tools. So you can use either draw beads or you can use the binder force to control it. Either increasing, if you see more wrinkling, you can increase the binder force. If you see more of tearing, then you can reduce the binder force. You can also do the nesting in this option itself. So currently in a single blank layout, you have 76% utilization, which you can change it to either parallel with a duplicate, could be opposing, could be duplicate, reflect about y-axis and positioning it, reflecting about x and y and positioning it, or you can use the auto nesting. You need to just select the just by positioning you can change your material utilization. You can also use this option to control your part to part margin, part to x edge margin, part to y edge margin, or you can even estimate the cost using the density value, or you can even move the option or the part. This is currently in sheet format. If I set it to coil, this is a double pass layout, such that first you are going to use this side of the blank, then you are going to rotate it and again bring it to this. You are going to utilize this part of the coil. This is a double pass when you are reflected the coil. This was crash form what we had set up. So now if we set up draw forming, you'll have binders. Add a new binder. You can use whole edge option here. I'll just change this to shader. Select any two nodes for defining the edge. I'll set this one here. So based upon that, it creates a line, and with the pressure level of medium, you can see a binder force, a restraining force of 196 kilonewtons is what it's required. I can hide this FLD plot. Now I'll see the effect of the binder or the blank folder on this component. I'll rerun the You can change the level to medium, low or high here. It has finished running. Now if you see, in some other regions it has improved, but in other regions it has failed. So instead of medium, I can say low, rerun the simulation, and choose the same file. Marginally it has improved. Barely 1 or 2 elements will be failing. Can check it with the percentage thinning results as well. It got thin because in this region you have excessive binder force. So you can either reduce your binder force or increase it to control your metal flow. Now coming to your blank fit, you need to select, come to tools and blank fit, select the part, specify the density of your material. You can use either rectangle, parallelogram or chevron fit. Click on blank fit. So once it has done with its setup of fitting a rectangle along the outside edge, it will exit out and create one rectangle box. That gives, if you are using a single blank layout, then you will be utilizing about 80% of your blank. The remaining will be going out as scrap. You can use this option to publish the report as well. You can say part geometry, rectangle fit. And if you check in the folder where it has it would have generated all the part images as a HTML format. And it will also give you a rectangle fit. The moment you run, it will save in the same folder rectangle fit. This rectangle fit will contain this rectangle line as well as the flattened blank shape. In your forming stages or incremental forming, you can use either you can create a surface out of your rectangle, or you can use this odd flat blank shape to set it up as incremental forming. This can be a starting point for your incremental forming. You can directly import this in HyperForm, generate the surface, mesh it, scale it in size, because this is your original size required to form the component. But since one step is reverse of all your forming stages, it doesn't know how many stages it has gone through. Hence, you need to scale your model based upon your material. If it's a softer material, you need to scale it by 20%. If it's hard material like advanced high strength steel, you need to scale up by around 15% of your blank thickness. It would either be 20% or 15% of your blank thickness. Best height and options are to check the distance between the edge and the part if you have a multi-part layout in your coil layout. Else, if it is for your single blank layout, you wouldn't be needing it. I hope you are clear with the one-step forming simulation. This is a reverse process wherein you are looking forward to get the flat blank shape rather than going through all the forming stages. This is a very quick method to get the idea of whether your component is formable or not in the first place. Then, if it is formable, what would be the material required to form that component? This is useful for not just the tool engineers but also people in costing and estimation department, wherein the material requisition order can be placed based upon the minimum material that is required to form each component. See, when this is your original flat blank shape, but you require some excess material to be available for your binder to hold and other operations to be carried out. So you need to scale up your blank. So currently this is 1103 into 738 mm. So this rectangle has to be scaled up, increased in size, such that you accommodate the effect of the binder on it. Also the other options during your trimming operations. So you need to always use slightly larger size of your blank than what is required to for your forming your original component. That is what goes as scrap. So you need to be very judicious in deciding how much extra material is required. If it's a soft material, you need to scale it up by 15%. Sorry, if it's a hard material, you need to scale it up by 15%. If it is a softer one, scale it up by around 20%, because that will expand a lot. That is useful when you are going or using this same blank for an incremental forming. I will now start off with the incremental forming. while being in this session, you can change the profile from radius one step to incremental radius. So this is the graphical user interface for incremental radius, similar to that of one step. You have the same pull down menus, same browsers, just that instead of one step you will see user process, standard 3D panning and rotating options. Along with that you have the auto process buttons. These are called as auto process buttons. This will help you to set up the gravity, single acting draw, single acting with support, double acting, flanging, trimming and spring back. Trimming is a pre-processing activity, hence it will not require any solver as such. You just use the trim line and delete the elements either inside or outside the formed blank. In the user process, you have options to similar to that of your auto process. You have process type as forming, gravity, trimming, lancing, or spring back. Then in the default process, you can right click and click on load process. You have the crash form, double acting draw with support, flanging, gravity explicit and implicit, single acting with support, and triple acting draw. Yes, it can be considered for as a result, but you should be looking more into your FLD or forming limit diagram than a percentage thinning. Percentage thinning is based on your total elongation of your material. You also can look for the percentage elongation or the percentage thinning based upon the type of simulation you are going to use the forming results to. If it's a crash result, then you cannot have more than certain percentage of thinning. So based upon the use case of your formed component, you can decide whether to consider your thinning results or not. From forming point of view, formability diagram should be more than sufficient. So I'll load this is a typical cup drawing model wherein you have try to ensure you have the standard naming conventions in your model. I'm deleting all the materials and properties which have already been assigned to this so that they can be recreated in a new way. So here is your top, which is nothing but your die, punch, blank and binder. So this is your currently this is set to single action draw. So I'll set this option to if you notice in this is called as the auto process window. Currently the process type is set as single acting draw. You can change it to flanging, gravity or any other option based upon the type of simulation you're running. Currently, we are not applying any draw beads. We are not setting up symmetry conditions. This draw direction is set to negative Z, wherein the tool will move in negative direction of Z direction axis. You are not running a hot forming or thermal forming, so it's set to off. This is a shell type, adaptivity set to 2. But if you notice, there are two tools which haven't been populated here. So always make sure you use either standard naming conventions or you select the right component here. I can set this as binder. Sorry, this is already selected. The moment you select these components, they get the component colors. So you need to assign everything line by line. So I'll activate the first blank component. So this is sheet component here. Material, I can select any of these. You can select any of these blank thickness is specified here. Once you are done with all the entries or fields in this line, come to the next line. So this is single acting draw, wherein your die will move along with the blank and hold the binder and then form the component. So die will move initially with the velocity of 2000 until the binder holds the blank. It will be moving with less than half of the velocity. Once the binder holds the blank, it moves with the double velocity. Punch, this remains stationary, so the amount of distance it's going to move is set to 0. Binder, again you have option for gap and force. The force results will always give you better option since you can control the amount of force acting on the blank. By default, this force you can increase it to say 30,000. Stroke is set to automatic. Now once you have specified all the values here, click on auto position. Each has its own use case, Samitra. One step is used whenever you want initial information about the component. Incremental is used by manufacturers if they want to understand the whole forming stages. So each has its own value. If it's only to get the flat blank shape, the amount of material that is required to form that component, then one step should be more than sufficient. Else, if you want to capture the entire forming stages, 3, 4, whatever number of stages are required, then incremental will give you more accurate information. That is more used by the manufacturers. So once you have auto position, click on apply. So this will automatically position the tools, assign them with all their material properties and thickness properties, and also give them the motion curves, renumber them, and then click on run. It will ask you to This will save radio's starter as well as engine file, and then start with running your radios solver. It has finished running. Unfortunately, you cannot view the results in incremental radios. You need to open your HyperView to check the results. This is HyperView, which is a post-processing tool. Here you will see the similar layout with the pull-down menu, standard visualization options, capturing your images or videos. This is for your session and results browser. You can change between the load cases and time. This is a model browser wherein you can isolate all your components. You can use this entity attributes to change it to transparent. Without applying any results, let us check if the motion is right or not. Okay, the motion seems to be good enough. So let us go to contour panel here. Here you will see different result types: strain, stress, mass, thickness, thinning, component displayed. Even if you say have all the tools, punch, binder and blank, the result will only be available for your blank, not for your tools. So this blank has got hint 28% in this region. This is typical of all your forming components which has this sort of corners. You can check how the contact forces are applied onto your blank. Your formability is more important. If you can see the thickness results, formability results is what you are going to be looking into. So your 1.2 mm blank became 1.38 in these regions. So this was regular result, what we are looking for. Apart from this, the main result what we need to be looking for is your forming limit diagram. So you need to add a study. Here the FLC curve is based on your strain hardening coefficient and blank thickness. So for this material we have run it with CRDQ. So this generally has the same 0.2 strain hardening coefficient, but the blank was 1.2. So always give the right blank thickness. So it first creates the FLC curve, true strain, select the component, apply. So if you see, very small region is marginally failing, but the rest region has lot of wrinkling occurring in this region. Visualization of 3D representation is currently not possible. It is possible only for few one-dimensional elements only. So this is the process of setting up incremental forming using auto process. The next option is using the user process. Splitting the screen is here. By default it is a single window. You need to set it to, you can automatically, the moment you set to FLD, it automatically creates the second window. You don't have to do it manually. It does it for you automatically. So if you want to take snapshot, you have option to take capture just the graphics area, capture the panel area, which is this region, dynamic rectangle, capture only the frame area. You can generate video, which is AVI format. I say graphics area, graphics image area, save to clipboard. This would most probably be saved into your either documents folder or your working directory, any of it. Or in certain cases, you can also ask it to save it to your working directory, where you have run the simulation into. Compression line is all the elements that are falling below the safe line. All these elements are getting compressed. So you will see either wrinkling occurring here or tearing occurring here in these regions. I'll show this again. Here you need to add it. Once you go to Tools, FLD, it will bring up with this window. Click on Add, specify the strain hardening coefficient for your material, specify the thickness, click on Apply. Then it will automatically split the window into two. Then come to FLD, change it to True Strain, Apply. Red line represents failure. Anything above that, your blank will be seeing tearing in the blank. You should not have any elements above your red line. So here I have loaded a model which only has a part and a blank. It does not have a binder or anything. So always make sure you have some extra land on your side of your component such that you use it to generate your binder. Binder is required to hold your blank. So always, if your original component is this region only, but here we have generated this extra region such that the binder is created based upon this extra region to hold the blank. So when you are generating a CAD geometry in your CAD environment, be it any other software, make sure you generate it with extra region such that you use that flat region for, or it could be even slightly curved region based upon your component, such that you use it to generate the binder. So here you have options to select or create new tools. If I take this bottom as the die, then I require the binder and punch for this component. You can use build setup tool from die surface or build setup tool from punch surface. This is already a die at the bottom. So blank is 2 mm. The clearance between the tools will be 20% of your blank thickness. So clearance between your two tools will be any of the two tools. Between the punch and the die, it will be 0.24 at the bottom dead center when your punch is completely into the die. For now, I'll hide the blank. So for binder source, it requires elements. I click on the element, on plane. To define a plane, it requires 3 nodes and a base point. So I'm going to select any 3 nodes that define a plane and a base point. So based upon the plane which I have selected, it selected these elements. So this will become the binder now. Only the highlighted white elements. Let's say here you can select machine type as double acting or single acting. I'll set up as double acting. Similar error could come out whenever you are setting it up. So it will ask you to save your HF file. Similar to HyperMesh, it will also ask you to save your HF file. So I'm going to remove the .hm and save it as HF file. Change the user process. Before starting, I'll delete all the session files. In my case, I have generated a bad file that automatically deletes the session files. You can start up HyperMesh and then change the profile to incremental radius. Any doubts in the meantime? Depending upon your geometry, you can use the outer skin as die and the inner skin as the punch. So if you are extracting, you can use the top skin as the die and the inside bottom skin as the punch surface. Here I'll use the same crash file which I had saved. You see the model should still contain the bind only that. I'll come to setup, tool setup, blank. I'll hide the blank. Double acting 1.2 mm thick. So it has generated the tools for you. You either need to have a punch or the die. Clearance is nothing but the gap between the two tools at the bottom dead center. So if your blank is 1 mm thick, when your punch is at the bottom dead center, which at the, wherein it meets with the die, then the clearance between the punch and die will be equal to the blank thickness plus 20% of the blank thickness. So total gap between the punch and the die will be 1.2 mm if your blank is 1 mm thick. So in this case the blank is 1.2, so it will be 1.2 plus 0.24. So 1.4 mm will be the total gap between your punch and the die at the bottom dead center. Bottom dead center is once your punch or the die has completely moved down into the opposing tool to form the component. So once you have generated the tools, it automatically assigns the materials, but you can delete them. Come to user process, process type, load the process, right click and select double acting draw. Remember we set it up as a double acting tool. So this is a forming type, this is not a spring back or any other stages, so it is set to forming. This is a shell type config is single blank. There are no multiple or layered blanks here. I'm not setting it up as a symmetry. Optimization is set to off. Animation count is by default set to 10. You can change it if at all you want to a higher value. Draw direction is set to Z. In this case, you need to draw direction always set to Z. Just that the values have to be added in negative direction. Whatever velocity, the distance move has to be in negative direction. Adaptivity is set to a level of 2. I'll tell you what the adaptivity means once we run the simulation and plot it. So before that, I'll show you. So this element is 17 units wide edge. Okay. So remember, this is 17 units wide. This is the blank. The moment you activate on the blank, it gets highlighted here. Select it from the database. Always make sure you have using standard naming convention like die, binder, punch or blank folder, so that based upon that it will automatically detect and position. So in double acting draw, the punch is moving from top to bottom. The binder is above the blank. The die is below the blank. Your blank is your datum or the plane. So all the tools will be positioned with respect to that. So if you notice, the binder is above, the die is below, the punch is above. Based upon the naming convention, it will automatically organize them. Once you have selected, right click, auto position. So it has positioned the tools. But you need to always make sure animation count is number of animation files you want it to be written. The A0 files or animation files. Always make note that the element normals are always pointing towards each other between the two moving tools. Say for instance, if I go to Shift plus F10, this will bring me to the normals panel. Shift plus F10, Shift key plus F10 will bring you to the normals panel. Components would be blank, punch and the binder. Select size of 10. So if you notice, the binder elements are going down towards the blank. The blank is moving up towards the binder. The punch is moving down towards the blank. So the punch and the blank and binder and the blank should always be opposing to each other. Else it will not be able to calculate the distance, what you are seeing here. It will only be generating 20 animation files with more, it will run for a slightly longer time to set the count to 20. For regular forming simulation, animation count of 10 should be more than sufficient. If you think you have multiple other tools, side cam tools, then it makes sense to add more animation count. So here I'll specify the value from -1000 to 20,000. Once you have assigned again, come to setup, components. Component is your blank, section is your thickness property, material is already assigned to this thing, so you don't have to follow this step of assigning to this component. It is only valid for your punch step. Right click. Here you don't need to do any of your auto tipping or undercut checks. Once you have auto position, click on create input. The moment you create input, all the material curves, the thickness properties, the contact properties are created and assigned to the individual components. Then right click, create input again, export the file, you can ask it to run. It will ask you to yes if you want. If you want to check the element normals, go to Shift plus F10, select the components whichever you want to check the element normals for. Make sure it is always set to the two or three moving tools. Let's say a value of 5 or 10, ask it to display. So if you see, the blank normals are moving up, the punch normals are moving down, the binder normals are moving towards the blank. They have to be opposing to each other. Only based upon that your tools will get positioned. So I think it has finished running. We can check the results. Let us first check if the tool motions are correct. Seems to be correct. So I'm going to check the percentage thinning. Hide the punch. So this region got thinned by 41%. So there could be effect of binder in this region. I can explain it after we have done with the post-processing. Again, you can check. Just because your blank is failing or having more percentage of thinning doesn't mean it could be failing in your forming limit. So you can check it. But here in this case, same region is failing because there is excessive thinning. This is hard material. Your HSLA material is supposed to be quite hard. So there is less elongation, hence you would see failing in such regions. Now if you plot it with elements, if you remember the element size was 17 when we checked in HyperForm. But these elements have got adapted or divided into smaller. So your 17 got divided into the first level of adaptivity into 4. Then further this 4 got divided into 4. So this is your 2 levels of adaptivity. This is your first level of adaptivity. This is your second level of adaptivity. Until it captures that feature, it keeps on adapting or dividing itself. The regions where it's not needed to adapt, it remains as it is. This is called as adaptivity. Coming back to the query about the element normals. If you feel the element normals are going in the wrong direction, you can use either the adjust normals or reverse normals. I'll do one thing. I'll hide this. Shift 10 component, say the binder, display normals. It is showing in this direction. I can say reverse normals, or I can say this element and say reverse normal, and I'll adjust normals elements by collector, which is your binder. Orientation element is or you can just say reverse normal for by collector binder. Just set this element as reverse normal. So I hope you are clear with the option of adjusting the element normals. Always they have to be pointing opposing to the moving tools with respect to the blank. Based upon element normals, it will automatically give all the positions and the timings. If you want to change the timing for individual tools, then come to motion, right click, properties, details. You would see which part is its mating part. You can say start time, end time, when is it absolute, or you can try to change the curve if you want. Else, this option should be more than sufficient. You can change the velocity with which it's going to move as well. Not necessarily that it has to be 5,000. It can be even 4,500 for the second motion. First can be moving with 2,500. So you can control the speed with which the tools move. If the element normals are correct, it will automatically position itself. Just that you need to specify the force value for your binder separately. It will not calculate it for you. You need to be giving some arbitrary value based upon your first initial run. If you want to create new material, activate the collectors, come to materials, create, could be any color you want, it doesn't matter. Type is elastoplastic. You will be using Hill orthotropic tabulated. There are two options, Hill tab 73 and Hill tab 43. You will be using 43. The 73 option is for hot forming, not for cold forming. You need to use create, edit. Specify the initial density, Young's modulus, Poisson's ratio. If you know the Rankford's coefficients, you can specify them as well. Else, you have an option to create materials in another way. If you hit M on the keyboard, it will bring up the bottom panel. Come to materials, create SLA, card image, Hill ortho, tabulated. Click on import curve. If you already have the stress strain, true stress strain curve, you can use it. Else, you can create your stress strain curve based upon a starting point, which is your yield point, end point, which is your strength coefficient, and finally the slope, which is your strain hardening coefficient. You should be aware of these three values. I'll say SS for stress strain curve. For a regular mild steel sort of material, I'll use this. Will create one curve. Click on return. This is based on power law. I'll come to hardening curve, select this SS curve, I click on create. Then I'll come to material, select this curve, click on edit card. It will automatically populate with these values, and then you can add the Rankford's coefficients. Once you have done this, you can click on add to database. By default, it will point to your materials database in your installation folder. This session is for question answers only, Ganesh. You can ask queries. Advanced mass scaling is an option wherein you don't have adaptivity in your elements. It automatically uses adapted size of elements. You need to mesh your blank with a size of 1 or anywhere ranging between 0.8 to 1.5 or 2 mm, if your model is in mm units. So it will not adapt, those elements will not get adapted, and it will add a non-structural mass to your blank such that your time step value will greatly reduce, and then your run times will improve. As in the sense, it will, if a normal run takes 1 hour, it will finish up within 15-20 minutes without any loss in your accuracy. It will automatically decide it for you. As long as you have followed the standard naming convention, it will automatically decide for you based upon the timings. You cannot see the effect of springs on your binder and all that. Here you are only seeing the effect of the tools, how the binder force they are getting acted upon. The effect of springs of your binder on your blank, that cannot be modeled in your forming simulation. As long as you are using the standard naming convention, you will be able to see all the add or delete your motion curves. Your element normals will decide your mating part. Your punch mates with the die. Your binder mates with the blank. These are called the mating part, where what it meets with. Your binder does not mate with the die. It doesn't go into the die. It holds the blank. That's why the mating part for your binder will be the die. For your binder will be the blank. Punch resting position is inside the die. Hence, its mating part will be the die. That's how you need to decide the mating part. That comes on your judgment. You cannot directly decide. You should be aware based upon the component that which region of your component has to be flanged, when it should be flanged. You cannot do flanging operations in first and do trimming operations later. You need to be running, you need to plan it accordingly such that you achieve your finished component within minimum number of stages. So based upon the component, you need to spend time, which are your flanging regions, which are the trimming holes, when can you trim, because if you are going to decide the size of your trimming hole initially will be oblong in shape, but when it gets formed, it should become circular in shape for your circular holes. So you need to be very careful about how you form the component, or when you do the trimming stages, when do you do the flanging stages. It comes on with some experience and your judgment about the component. Also, how the press is available. Is it a double acting or a single acting? Do you have the flanging presses available or tools necessary for that? It comes out of experience. Till your binder holds the blank, the punch will be moving slowly. After it moves, after a binder holds the blank, then it moves with fast. So in this case, this motion can be 5000. This motion can be set to 2000 or 2500. So until your binder holds the blank, your punch will be moving with half the velocity. roughly half the velocity. So once this is distance your binder is going to travel to hold the blank. That's why it's moving very fast. But till that motion completes, you need to be moving with slow velocity. Distance is based upon an element normal. That's what I have been telling you. Distance is based upon the element normal. If the element normals are pointing in the right direction, it will calculate the distance automatically. I did not specify this value. Else, you can measure the distance using your F4. I'll calculate the distance between these two. So this gives me an arbitrary direction of, say, 1.77. This is direct straight line. Okay, 1.778. The blank is 1.2 mm thick. Correct? So half of the blank comes above and half of the blank comes below. Plus we have given some clearance of, say, 20% of the blank thickness, which is 0.2. So according to our calculation, it is 0.94. According to this, it is 0.18. So this is the total distance how you need to calculate between individual tools using the F4 panel. Dinesh, you can ask. I think the other people are sending the chat messages. You can, I'm not sure if you're able to hear me. You're not applying the load. There's no binder. How will you apply the load on the blank? You'll only be looking into the punch tonnage. There will not be any binder. There's nothing to hold the blank at all in the crash forming. It's just punch hitting the blank till the end of the Yes, Dinesh, this is all about the forming presses only. You're not applying the load at all in crash forming. The velocity itself will apply the load. Nothing. There is no die casting. This is not a session for die casting. This is only for forming. Sheet metal stamping only, not for die casting. In triple action draw, there are two binders, one from top, one from bottom. This is a triple action. Yeah, this session is getting recorded, and I'll upload you with the link where you can access the video. That is to be calculated or done from testing by the material supplier. This is along 0 direction about 45 degrees and along 90 degrees value along the plane of the blank. This has to be done by testing by the material supplier. I'm not sure about what you mean by conical or elliptical die edge. But I can check and I can let you know. If you have a UP file, you can. No, it is not based on material properties, Ganesh. It's only based on material thickness, blank thickness. You can click on, instead of load process, about this UP, you can go to the location wherever you have saved your UP file and then import that file. Green line is a safety line. All elements below that line will be safe. Or between the green line and the yellow line will be safe. Anything below the green line will be seeing compression or wrinkling. If you have any queries, you can forward it to edu-support@india.altair.com. I repeat, you can send your queries to edu- Not necessary, Danish. Only the blank thickness should be more than sufficient for you. Strength factor is meant for blank only, not for your punches. Adaptivity is division of elements in the regions where it needs to capture those features. It gets divided only for the blank, not for the tools. Alright, then I'll end today's session. Pretty soon we'll upload the recording, and then I will also send you the date for next webinar. The procedure remains same, just that you need to mesh your blank with hexa elements. We'll let you know. We haven't decided it yet. We'll let you know about the next date for the webinar. It will automatically take care of the contacts for the solids. You don't have to do a special contact for them. You can send in all your queries to support@india.altair.com. It was nice interacting with you all. Thank you. You can contact us, Danish, whenever you face any licensing issues. We'll send it to you. You need to. I hope you have already registered. Once you are registered, we'll immediately send you the license to download. Thank you. Have a good day.